It's great being here. Welcome to my session, Serverless Applications with Redis. I'm Adam. I've been developing backend and infrastructure software for the last decade. I've been an infrastructure developer for Waze in its startup days, backend developer at Yahoo, and the CTO at Vuser, a location-based questions and answers startup. And now I'm the developer and developer relations at Binaris. And Binaris is a serverless platform. I'll elaborate about what we do later on. And by DevRel, I'm organizing serverless conferences, speaking in events like that, and that's actually a lot of fun. We have a serverless conference, a serverless Tel Aviv conference coming in June. So if you like, just search for us, and we'll be happy if you join. And my session is actually not strictly about serverless technology. It's about your next product or your next feature that you're going to implement. We're all going to add features to our products, and I'd like to argue that if we're going to do it in serverless with Redis, we're going to benefit fast development cycles, ultra-fast development cycles, low latency, high concurrency, and we're going to have a hosted solution that will not need to maintain ourselves. And just a quick question, how many of you are using Redis in production? That's not a great surprise, it's a Redis conference. How many of you are using serverless functions in production? Not so many, and I'll try to hopefully bridge that gap during this session, because I think these two technologies work extremely well together. So, before we describe the internals of a serverless function, let's talk about the infrastructure evolution of the last decade and a half. We began with actual physical servers we maintained in our business. We had to purchase them. We had to install operating system, install hard drives, connect network cables, switches, routers, all that. And on top of that, we had to install operating system and web servers and web application servers. And only weeks or even months after we bought the servers, we could write the first line of code, of business logic code that served our purposes. And then we had to maintain them and cool them and whatnot. And scaling took weeks because we had to buy the servers, install them. That was the old days. And then, in about a decade ago, public clouds started presenting virtual machines, and all the undifferentiated heavy lifting of buying a server, installing it, and so on, were delegated to the public cloud provider. And we only had to take care of operating system, web servers, web application servers, and all of that stuff. And scaling now takes minutes, not weeks, but it's still a lot of operational burden. And about 5 years ago came containers, mainly Docker. And we don't have to deal with the operating system, but we have to deal with the Docker images. And are any of you using Kubernetes? Loving it? Really? Okay. It's a burden, even if you like it, and you have to spend a lot of effort in orchestrating all these pods and containers. And then, about 4 years ago, a new technology or concept emerged, serverless. Just give the cloud provider your business logic code, and they will run it for you. They will only charge you for the time the code is executed, so there's no idle time that you're paying for. And this is actually probably the futuristic way, or even the modern way of writing code. Okay, so let's look at the internal or the general structure of a serverless function. There is typically an HTTP call. There are other triggers, but typically there is an HTTP call that can come from the internet or from another application within our VPC. It hits a load balancer, which, thanks heavens, is managed by the cloud provider and not by us. And that load balancer is delegating or passing the call to one of the instances that are running our function. Now, this is actually an implementation detail, but it's important. Our functions are running inside containers. They're maintained by the cloud provider. but they're containers. And when we need to scale up, when the cloud provider scales up these containers, they're spawning new containers, and the call is sent to the function inside that container. And again, when there's no load, containers start dying, and the calls are redirected to the existing containers. So I'd like to have an analogy of the function lifecycle. We're probably all coffee drinkers here. So if you have a cup of coffee, a mug in your hand, and you need some coffee, you just sip, and it's a very quick operation. But if you are first to come to the office and you have to brew the coffee and start the machine, it's going to take quite a while. And we call that, in the serverless world, warm start. There's a container waiting for you, and you just call it, and it returns your function. And that is cold start. There's no container available, and the cloud provider just starts a container for you. So the analogy goes that if an HTTP call hits the cloud, it checks whether there's an available container. Yes, sip some coffee, fast execution of function, warm latency, perfect. No, brew coffee, it's going to take a while, I'm starting the container. And we're talking in AWS numbers. These are tens to even 100 millisecond latency for warm start. And these are could be a second or more before the response for a cold start returns, which means when you scale up, you have some kind of latency bumps when you hit the new container or the cold start. So the anatomy of a function, to recap that part, it is stateless because the container can disappear instantly, reappear, and without any previous state. Functions are containerized. Just opening a stack here, they're mostly containerized. There are other solutions, but if you're using AWS, Google, Azure, Binaris, then all the major ones, then they're mostly containerized. And we need a data solution because a meaningful function usually interacts with a data storage, and we need that. And suppose that's your boss. I hope not. And that creepy boss tells you that we need a hit counter. And a hit counter, for those of you not doing web work, is a function or a URL endpoint that you call whenever a user enters a web page or opens a web page. And then we can know how many users or visitors visited that page, like Google Analytics, right? And we want that. So our top-notch developer comes with this function, serverless hit counter. It imports Redis. It opens a connection to Redis here on the fourth line. And then we'll have a function that gets the body, the HTTP body. It extracts the link from that body. And then it increases using Redis Inker for that link and returns the link and how many users already visited that count. Now it is important to note that there are two parts for this code. There's the top part that is executed only once. And there's a function that is executed whenever somebody calls that function with a new link that should be increased. And we're reusing that connection. And that's a pretty important thing to note because we are dramatically reducing the number of connections we're opening to our Redis instance by reusing that. And that's fast. And by fast, I mean it's fast to develop. We actually saw that we have a function that's literally, 5 or 6 lines of code without the documentation. And that function is the complete solution for a hit counter. We don't have to do any other operations, install servers, Kubernetes, nothing. We give that to our cloud provider, and it works. And it's fast because we're reusing a connection, right? Because we don't have to open a connection to Redis every time we have a hit. And the question goes whether Redis is a good choice for our application, hit counter or any other application. And I hope that I've convinced you that it's good in terms of development velocity. It's very easy to write code that way. It's affordable because unless there are some extreme cases, but you're only paying for the time this code runs, and it's not that much. And there are huge organizations with billions of monthly calls for news feeds and so on that running purely serverless today. It works with our existing data because it's just Python or, God forbid, Node.js code that interacts with the existing Redis. We have all the libraries. And the question remains whether it's a good fit in terms of concurrency and latency, because we have a fixed number of Redis instances, right? But the serverless functions fluctuate. There could be a lot of functions running at the same time. So let's review the concurrency. This number of concurrent containers or functions running is the typical limit in Amazon. It is similar in other providers. About 1,000. It could be changed. It's a soft limit, but we're talking about orders of magnitude here. And assuming that our function takes 100 milliseconds, which is a lot of time to execute, we're talking about 10,000 calls per second, which is, I think, for a lot of application is more than enough in terms of capacity. And Redis connection count equals the number of containers, right? Not the number of function running, not the number of functions running. So we only stay with about 1,000 open connections when we're at full capacity. And as of Redis 2.6, the default in Redis, and I'm talking about simple instances, is 10,000. So, and this could be increased, so we're not talking about any problem here. And actually, I executed this Redis benchmark yesterday. It has a miracle happened, and some requests returned in less than 0 milliseconds. But for the most part, we're talking about less than 2 or 3 milliseconds. So there's no latency issue with opening 1,000 connections to Redis and executing queries on it. So development velocity, affordable, and works with our data. Concurrency and latency is a non-issue even if our load fluctuates with a decent Redis solution. So to conclude, in my opinion, serverless functions are gold. They're fast to develop, they're easy, and they integrate extremely well with Redis. So they're probably a very good solution to your next feature or application. Redis can definitely take the load, unlike a lot of other solutions out there. You have to know your concurrency, because even though Redis can take the load, if you take too small an instance, it's not going to work. You have to have a good estimation of concurrency. And if you have to keep just one thing in mind from this session, keep an open connection and reuse it. Don't open a new connection whenever your function is executed. In a quick shift, a little bit about binaries. We do low latency fast function as a service. We work within AWS, and unlike AWS, or other providers which run in orders of magnitude of tens to hundreds of milliseconds, we have no cold latencies, and our typical latency guaranteed in SLA is 3 milliseconds. So if you care about latency and you want fast response, binaries and Redis is a pretty appealing combination. You can come and talk to us about it later. We have a public beta. You can just open our site, binaries.com, get an API key, and get a free instance from Redis Labs, and have your first. We have a Redis tutorial. You can probably get a working network endpoint with Redis in 10 minutes. And lastly, this is actually my last day at Binaries. It's been an amazing 2 years, and I'd like to thank the wonderful team at Binaries for these years and for the ongoing operation that is happening now in the United States. I'm seeking my next adventures. If you want to reach out, that's me on Twitter. And thank you everybody, and thanks Itamar for hosting me here. Thank you.